Hello, fifth period. This week we're going to do some geometry. We're all going to do the same thing. That being said, if you check your jump rope and you notice that you have less than a 3, please feel free to email me or Ms. Anchorman and we can assign you some different work that would act as a reassessment to replace some of your grades if they are less than a 3. For the rest of you, we're going to try learning about volume. There have been a couple of you who have chosen this activity in the past 3 weeks. If you are one of those people, you may either do it again or email me and I will give you a more challenging task. But those of you did not really get much of an explanation, so this is the volume lesson with some explanation of how to do it. So we're going to look at different shapes and how to find their volume. So if we think about volume is, I think you've learned this in science this year, is like the amount of space that something takes up. So if we think about like a bottle of water, it's like how much water is going to fit inside that. And it's measured in different units. This is like, you can measure, right, liquid in like liters, right? That would be the metric. It's also 33.8 fluid ounces. And then like, if you think about cubes, little cubes, it would be like cubic inches or cubic centimeters. So think about volume. There's a couple ways to think about it. One of them is thinking about stacking. So blocks, these are Duplos. Each of these blocks is 2 by 1, 2, 3, 4, 5, 6, 2 by 6. So its area would be 12, and we could think about it as like a height of 1. So if we have this, which is 12 units cube, 12 square units, for example, then, or actually it would be 12 cubic units because 6 by 2 by 1, right? 6 times 2 times 1 is 12. So each of these blocks would be 12 cubic units. We're going to call each of these pips, I think is what Lego calls them, a unit. So then if we stack it on top of each other, we have 2 that are 12. Now we have 24 cubic units. If we have another one, it'd be 36. And the last one would be 48. So we could think about finding this one's volume by looking at its width, which would be 2, its length, which is 6, 12, times its height, which is 4, equals 48. So this volume of this piece would be 48 cubic units. I can do the same thing with like something that's circular. So these are some CDs. Let's see what I got interesting in here. Forrest Gump soundtrack, Wu-Tang, more Forrest Gump, some Atmosphere. I don't know if any of you guys know that band. Dr. Dre, Jay-Z, No Doubt, Melissa Etheridge, some like mixed CDs that we made. TLC, Jewel, more Jewel, Fiona Apple. Anyway, so if you think about each of these CDs, Bob Marley, as, right, it's a disc, it's pretty thin, and I could find the area of this circle by doing pi r squared, which is the formula for the area of a circle. R being its radius. Radius is the distance from here to here, halfway across the circle. And so the radius would be from here, from the middle to the end. And you could think about that, find the area of this. So let's try that. I'm going to use a ruler. I'm going to measure from the middle. I'm going to measure in centimeters because metric units are just better. So if I measure from the middle to the edge, I get about 6 centimeters. So pi, which is 3.14 approximately, times the radius squared. So radius is 6 squared. So 6 times 6 would be 36 times pi. So I'm just going to use my calculator and find 3.14 times 36, 113.04. So the area of this CD is approximately 113 centimeters. And I'm going to just pretend for a minute that each of these CDs is 1 centimeter high. I think it's less than that. But if you picture a whole cylinder, if I stack a bunch of these on top of each other, then I can find the volume of the whole stack by taking the area of one and multiplying it by the number in the stack. If each of the width of the stack is 1. So I don't know how many there are here, but that's how I would do it. You take the area of the base, which would be the circle, and multiply by the height of the whole stack. So you could do that with another cylinder. This is a cup. By measuring, so I'm going to write this down. I'm going to show you exactly how to do this. So the volume for a cylinder equals pi r squared, which is the area of the base, times its height. Now, this cup is actually not quite cylindrical because the bottom of the cup is slightly smaller than the top of the cup, but for this purpose of this demonstration, we're going to pretend it's a perfect cylinder. So this is what the formula would look like. Volume, V, equals pi r squared times height. So the first thing I'm going to do is measure the radius of that. So I'm going to measure all the way across in centimeters, which is 8.5. So 8.5 is my diameter, which is all the way across, and I divide it by 2 to get the radius. So my radius equals 4.25. And then height of this cup is 16 centimeters. So the height equals 16 centimeters. So I just put down on the side radius and height. And then I'm going to use my formula and plug those numbers into my formula. So pi times, and instead of r, I'm writing 4.25 squared times height, which was 16. So it looks something like that. Now, instead of pi, I'm going to write 3.14 times 4.25 squared times 16. So then I could just use my calculator to figure that out. So if we want to follow order of operations, we do exponents first. So 4.25 times 4.25 is 18.065 times 3.14 times 16 is volume equals 907.46. And we want to include units, which are going to be centimeters cubed. Volume is a cubic measurement, meaning it's measuring in 3 dimensions, right? Cubic is to the 3rd power, 3 dimensions. So this would be the volume of this cup. And I'm pretty sure that 1 cubic centimeter is like equal of water is equal to a milliliter. So like this cup probably holds about 900 milliliters of water if I actually filled it up, right? This is a whole liter. It looks like it would be, and a liter is 1,000, so it looks like it would fit, ish, with 100 milliliters or so to go. So we can measure cylinders. The assignment that I assigned for the week includes this as an option, a cylinder. Also includes what is called a rectangular prism. So basically something rectangular, but that's 3-dimensional. So I can measure the book, and the formula for a rectangular prism is just its height, its width times its length times its height. Width times length times height. So basically all of the 3 measurements of it multiplied together. I'm going to try something on my phone. So if you have an iPhone, it does have a measure app. It looks like that. And you can use it to measure something. So I'm going to try to do that with this book. You find an edge, you measure to the other edge, and then I'm going to measure like that, and I'm going to measure down reset. Let's try this again. Up, and then across, and then so can I do that at the same time? Nope. Okay. Sorry about this. Over. So it's gonna look something like this, right? It shows the measurements 6 inches across, 9 inches down, and I was able to measure the height of the book as well, but it doesn't save all those 3 measurements on the picture together, or at least not this time. I haven't done a whole lot of experimenting with it, but that's just kind of fun way. I can use my ruler too. But basically, the volume of this book is going to be 9, which is its length, times 6, which is its width, times 2, which is its height. And this time it's measured in inches. So 9 times 6 is 54. 54 times 2 would be 108. 108, and this would be in inches cubed. So that's the volume of that book. There's a couple other shapes that we have options to. Like this is the top of a puzzle box, and it's like a triangle. It's called a triangular prism. And you measure this volume by doing the same thing as if you had a rectangular prism. So length, width, and then height. And then you just multiply all those together and divide by 2. Because actually, if you were to have another piece exactly this shape on the other side, you can imagine that it would make like a square, right? So you would take, so this is half of the volume as if we had a rectangle. So you would measure it, height, width, length, and then divide what you get by 2. We also have like a sphere. A sphere would be a little bit harder to measure because you have to find the radius. The formula for the volume of a sphere is 4/3 times pi times the radius cubed. You could measure like a cross, so that's about 14 inches across, and then divide by 2 to find your radius, and then the only other thing you need is pi, which is 3.14. So for this activity, you would use 3.14 for pi for volume. So those are just some examples of shapes that we have. We have like a sphere, a cylinder type shape, a rectangular prism, You could also do like a cone. I couldn't actually find something in my house that was cone shaped, but there is the volume of a cone is one of the options on the worksheet. So basically, the assignment for this week is finding 3 things in your house and measure and calculating their volume. So what I want is a picture of the object, and then a drawing that's showing its measurement. So for example, you would want, if I was using the cup, I don't have to be able to draw a cup perfectly. I don't care that it looks like a cup. What I want you to do is draw a cylinder, right? And show the measurement. So like show that the height, the radius is 3 and maybe the height is 5. So you're showing each of the measurements of the piece. The assignment, when I'm posting, it has formulas and then pictures of the shapes with the letters are labeling the parts. So it would look like if I had a cone, for example, it's showing you R and then H. So the cone is showing this, that this R is the radius, and that's the measurement for radius, and H is representing height, which is that. And then the formula looks like this, which is volume equals pi times radius squared times height divided by 3. So it shows you where you get those numbers. So the radius is R, the height is H, and then the other ones you don't have to measure. So what I want you to do is find 3 things in your house that are these shapes, do some measurements, and attempt to find the volume. I want you to include units. I would like it if you could include a picture of the object, or a drawing, or both, that show your different measurements. And then how you use the formula. So showing where you plugged in the numbers. So this is brand new for us. So the goal is for you to just do your best, almost like a pre-assessment, and we'll see how it goes. And again, as a reminder, if you have any scores in jump rope that are less than a 3 and you'd rather spend your time this week doing a reassessment to bring those scores up, please let me know, and I'll make sure that we can get that done. Good luck, and please tell me if you have any questions.